Now in this case we want the optical path length. So we have wavelength is 600 nanometers, dE is 1.6 by 10 to the minus 6 meters, and we have a refractive index of 1.5. So optical path length equals n times the actual physical distance, which is 1.5 times 1.6 by 10 to the minus 6 meters, which is 2.4 by 10 to the minus 6 meters. Now B, we've got the wavelength in the medium is the wavelength in a vacuum over n, which is 600 nanometers over 1.5, and that is 400 nanometers. So we've got a certain distance through this medium, and we've got light going through there or just through here, and this is 1.6 microns. So the path difference, because in here it's just d, and in here it is nd. So it is just the difference between the two, which is d times n minus 1, which is 1.6 by 10 to the minus 6 times 1.5 minus 1, and that is 1.6 by 10 to the minus 6 times 0.5. So we have 8 by 10 to the minus 7 meters. Then finally we have a phase difference. Remember that the phase difference over 2 pi equals the path length difference over lambda. So we have phi equals 2 pi times path length difference over lambda, which is 2 pi times 8 by 10 to the minus 7 over 600 by 10 to the minus 9, and that is 8 pi over 3 radians. Now that's more than 2 pi, so in fact that is 2 pi plus, which should be 6 pi over 3, plus 2 pi over 3. So it is a whole wave plus 2 pi over 3 radians.